In this video, we are to show that x to power 4 minus x to power 2 minus 1 is equal to 0. If we are given log to base x of y is equal to log to base y of x, and log to base x of x minus y in a bracket is equal to log to base y of x plus y in a bracket, we are given some conditions. X is greater than 0 and x is not equal to 1. Also, y is greater than 0 and y is not equal to 1. Before I proceed, I would like you to do me a favor. Like this video, subscribe to my channel, and also leave your comment in the comment section. This is an act of love to share, and love doesn't cost a thing. So please share this video. Now, back to the question. We are going to first of all start with the first equation, which is log to base x of y is equal to log to base y of x. In logarithm, we can apply the rule where we swap positions of the numbers. For example, if I have log to base a of b, it will be 1 over log to base b of a. I will apply this rule here. So if I have log to base y of x, is the same thing as log to base 1 over log to base x of y. So instead of putting log to base y of x, I will put 1 over log to base x of y in place of it in the right hand side of the first equation. So log to base x of y is equal to 1 over log to base x of y. Now we need to cross multiply. If we cross multiply, we'll have log to base x of y all squared is equal to 1. Having done this, we can now find the square root of both sides, or square root both sides. If I square root both sides, I will have plus or minus root 1. Of course, root 1 is 1. So I have plus or minus 1 as log to base x of y. Now that means that log to base x of y is equal to plus 1. In this case, x will now be x raised to power 1 rather will now be y. I'm converting from logarithm to indices. Let us recall that if I have log to base a of b is equal to, let's say, c, then a raised to power c is b. This law is applied in this case. Now, let us also remember that log to base x of y is equal to minus 1. Then x raised to power minus 1 is equal to y, applying this law here. However, our x cannot be equal to y because x is equal to y here. Our x cannot be equal to y. Why? Because if we check this argument, x minus y, if we now put in log to base x of, let's say, x substitutes y or y substitute x, that becomes y minus y. We are going to get a 0, which is not equal to this. So our x cannot be equal to y. That means that we are going to take this expression or this equation. So substituting this expression for y and x into the second equation, we have log to base x of x minus y is equal to log to base y of x plus y. Let us remember that y is 1 over x as we have it here. So I'm going to put 1 over x in place of y anywhere I see y in the second equation. So log to base x of x minus 1 over y, 1 over x rather, is equal to log to base 1 over x of x plus 1 over x. Now I'm going to convert this now to power. That becomes log to base x minus 1 of x plus 1 over x is my log to base x of x minus 1 over x. Now in logarithm rather, we also know that if the base has power, say log to base a of b, The base has the power, and this is the number or the argument. I am going to have 1 over p log to base a of b. So I'll apply this law in this case. So instead of writing this, I will write minus 1 over 1 log to base x plus 1 over x, which is log to base x minus 1 over x. Of course, 1 over 1 is 1. So I have minus log to base x plus 1 over x equals log to base x of x minus 1 over x. Now I will bring this side of the equation to the other side of the equation. So let me go up. It becomes log to base x of x minus 1 over x plus log to base x. I'm going to put let me put the x here, please. So log to base x of x plus 1 over x is equal to 0. Yes. So let us apply product law of logarithm. In product law, log to base a of b plus log to base a of c will give me log to base a of b times c. So I will apply it here. So I will take one of the log to base x and multiply the terms in brackets. X plus 1 over x is equal to 0. The next thing is to clear this logarithm. So I will take log of base x to both sides, or I will convert this logarithmic expression to exponential expression. If I'm to convert to exponential expression, let us remember that log to base a of b equals to c will give me a raised to power c equals to b. So I will express this in this form. So my x now will have this power 0, and then all these will multiply themselves. X minus 1 over x, then x plus 1 over x will give me x to power 0. X to power 0 is 1. So let us open these brackets. X times x is x squared. X times 1 over x is 1 over x times x, which is 1. And minus 1 over x times x will give me minus 1. Minus 1 over x times 1 over x will give me 1 over x squared. Minus, please, 1 over x squared. This and this will cancel out because they are equal and opposite. So x squared minus 1 over x squared equals to 1. Let us multiply through by x squared. Multiplying through by x squared, we have x raised to power 4 minus 1 over x squared times x squared equals to x squared. This will cancel this, remaining 1. So x raised to power 4 minus 1 is equal to x squared. So let's bring this x squared to this other side. So x to power 4 minus x squared minus 1 is equal to 0. This is what we are required to show in the original question.